Welcome to my channel. Today we'll start miscellaneous exercise 6 of trigonometry and bearing from question number 2. In this question we have to find sine alpha, tan alpha and the secant alpha value if cos alpha is equals to minus 5 by 13, whereas the angle is in between 90 degree to 180 degree, which means that your angle is in the second quadrant, and in the second quadrant we know that the value of x is negative. That's why you can see that the cos alpha is equals to negative of 5 by 13. So value of x is already negative here. So let's solve this question. The cos alpha is equals to minus 5 by 13, and we know that trigonometric ratios with the help of unit circle. We know that sine alpha is equals to y, cos alpha is equals to x, and tan alpha is equals to y divided by x. And further we know that the equation of the unit circle is equals to x square plus y square is equals to 1. So here is the value of cos alpha is given. So cos alpha is equals to minus 5 by 13, which mean that the value of x is equals to minus 5 by 13. So x is equals to minus 5 by 13. To get the value of y, we will put the value of x in the equation of the unit circle. So putting the value of x here and doing some mathematical manipulations, we will get the value of y equals to 12 by 13. So this value is equals to sine alpha is equals to y. So the sine alpha is equals to 12 by 13. Now to calculate the tan alpha, we know that it is equals to y divided by x. So we have the value of y here and we have the value of x here. So we will divide y over x. 13 will be cancelled with the 13, and the final answer for tan alpha is equals to minus 12 by 5. So tan alpha is also negative because it is in the second quadrant. Now to find the secant alpha, as we know that the secant alpha is a reciprocal of cos alpha, so we will take the reciprocal of the value of the cos alpha, which is equals to minus 5 by 13, and the reciprocal of that is equals to 13 by 5 minus. So that's all about this question. Now moving toward the third question. The angle of elevation of hot air balloon 500 meter away climbing up vertically changes from 30 degree to 60 degree in 100 seconds. So here is a balloon which is 500 meter away from the point from where the angle of elevation is 30 degree. This angle of elevation change to 60 degree as the balloon moves upward and in 100 seconds. To calculate the speed of the balloon, we have to find the first initial position of the balloon. So to calculate the initial position of the balloon, which is h1 height from the ground level, we need to solve the triangle in which the angle is 30 degree. To solve that, as you know that we have the base value, we need to calculate the value of the perpendicular, which is h1, and the angle of this triangle is 30 degree. So the most preferable ratio is the tan theta, perpendicular divided by base. Putting the values of angle and the base, we will get the value of perpendicular, which is equals to 288.68 meters. Now this is the initial position of the balloon when time is 0 seconds. Now after 100 seconds, the balloon reach to the height h2. Now we need to calculate the height h2 from the ground. To do that, we have to solve the triangle which having 60 degree angle. So again we use tan theta and putting the value for tan 60 degree, and h2 is the height of the balloon for the second triangle after 100 seconds from the ground, and this h2 is equals to 866 meter. Now we only need the distance from initial position to the final position. We have the distance of balloon first position from the ground level, and we have the second distance of balloon from the ground level. So now we will have to calculate this h height which balloon travels in 100 seconds. To calculate this height, we have to minus the h2 from h1. So now h2 minus h1 is equals to the distance traveled in 100 seconds. So h is equals to 866 minus 288.68, and final answer is 577 meter. To calculate the upward speed in meters per second, we use the formula of velocity, which is equals to distance divided by time. Here distance is equals to h and time is equals to t. We have the value of time, which is 100 seconds, and we have the value of distance, which is 577 meter. Now putting the value into the equation, we will get the upward speed in meters per second is equals to 5.77 meter per second. So that's all about question number 3. Now moving toward the question number 4. Find the value of a for the following figure. So this is the figure. We need to calculate the distance between C and the D. Here you can see we have the two triangles. The perpendicular of both triangle is common, but the hypotenuse of both of the triangles is different. So here the first triangle AC, the value of hypotenuse is 14, and for the second triangle the value of hypotenuse AD is equals to 16. First we have to calculate the triangle ABC and calculate the base from B to C. Then we have to calculate the triangle ABD and calculate the base B and D. Then we need to subtract the base BD from BC and we will get the distance CD, which is equals to A. Now to calculate the distance between the B and C, which is denoted as x1, so we use the Pythagoras theorem. Hypotenuse square is equals to perpendicular square plus base square. Now we need base value. So base square is equals to hypotenuse square minus perpendicular square. So putting the value of hypotenuse and perpendicular, and we will get the value of x1, which is equals to 9.79. Now to calculate the base of second triangle, which is denoted here as x2, to calculate this, we again use the Pythagoras theorem. The base square is equals to hypotenuse square minus perpendicular square. Now putting the value of perpendicular and the hypotenuse, we will get the base of our second triangle, which is equals to 12.48. Now we need to calculate the distance between C and D, which is the difference of both of the bases, x2 minus x1. So to calculate that, we will subtract x2 from x1 and we will get the value of A, which is equals to 2.69. So that's all about the question number 4. Now moving toward the question number 5. The area of right triangle is 50 centimeter square. One of its angle is 45 degree. Find the length of the side. We need to calculate the length of base and length of altitude. Here I show perpendicular with the altitude, because perpendicular and altitude are similar things. The perpendicular is perpendicular to the base value, but the altitude is perpendicular to the base plus it also joins the opposite vertex of the triangle. So here this perpendicular is fulfilling our both of the condition. It is perpendicular to the base value and also connected with the vertex A. So that's why it is known as altitude. And this is the hypotenuse side. We need to calculate all these three sides with this information, the area and the angle. So the area of the triangle is equals to 1 over 2 base multiplied by altitude. So now we have information when angle of a triangle is 45 degree, it is an isosceles triangle in which two of its sides are equal. So here are the two sides. For 45 degree, the altitude must equals to the base value. So perpendicular and the base value are equals to each other. We assume that altitude is equals to base and base is equals to some value x. Now putting the value of x in place of base and in place of altitude. Now solving this equation, we will get the value of x is equals to 10. As we assume that x is equals to base and x is equals to altitude, so it's mean that our altitude is equals to 10 centimeter and our base also is equals to 10 centimeter. Now we have two sides of a right angle triangle, so we can use the Pythagoras theorem. The Pythagoras theorem is equals to hypotenuse square is equals to perpendicular square plus base square. Putting the value and doing some mathematical work, we will get the value of hypotenuse, which is equals to 14.14 centimeter. So that's all about question number 5. The remaining questions 6, 7 and 8 will be solved in my upcoming next video. Thank you very much.